are there in any state, there has to be some queue or some space to hold those waiting processes. So we have three major queues with us regarding processes where a process may be waiting or where a process may be waiting for some event to occur, right? So job queue corresponds to the new state. So whenever a process is created, it will be submitted to job queue, and its state in the job queue is the new. From job queue, a process will be shifted to ready state, and in the ready state, the queue is named as ready queue. Ready queue belongs to main memory, and when a process is in ready queue, it has been allocated all the resources and it is waiting for the CPU to get executed. So a process in ready queue is ready to execute. Device queues belongs to the waiting state or the IO devices. So when a process is waiting for some IO device, it is placed in the device queue, right? So there may be multiple processes in job queue, there may be multiple processes in ready queue, there may be multiple processes in the device queue, but only one process will be there in the running state, and that's why we don't have a requirement of the queue in the running state, right? And if we have multiple processes in our queues, there has to be some policy to pick up a process from these queues to shift to other state. If we talk about the job queue, a process has to be picked up from the job queue and has to be submitted to the ready queue. So the polisher or the program which selects a process from job queue is named as long-term scheduler. A scheduler is one which schedules the processes, which picks up a process or which defines the order in which the processes will go forward. That is the definition of scheduler. So long-term scheduler is one which picks up a process from job queue and put it to the ready queue. So long-term scheduler defines the degree of multi-programming of the system, because multi-programming means when multiple programs are loaded into main memory, and long-term scheduler is responsible to put a program from job queue to main memory. That's why this long-term scheduler is responsible for the degree of multi-programming, or long-term scheduler defines the degree of multi-programming, right? There may be two types of processes, or the processes can be categorized into two types: IO bound processes and CPU bound processes. So IO bound processes are those processes, IO bound processes means a process which is having more of IO instructions than the CPU instructions. Like a process may be executed in like CPU instructions, then IO instructions, then CPU instructions, then IO instructions, then CPU instructions, and so on. So CPU instructions means the computational instructions. IO instructions means some IO operations are required for those instructions. So IO bound processes are those processes in which more of the instructions are corresponding to IO devices and less are of computational instructions, whereas CPU bound processes are those processes which spend more of the time in the CPU as compared to the IO devices. So there has to be a proper balance between number of IO processes and number of CPU processes which are placed in the main memory of the system. And it is the responsibility of your long-term scheduler which puts processes into main memory. Why it is so important to have a proper balance between IO bound processes and CPU bound processes in the system? Because if all the processes are of IO bound processes in the system, so most of the processes will be computing the IO instructions, and when IO instructions are executed, CPU will be idle for that time. So you are underutilizing your CPU. This is the case of IO bound processes. If more of the IO bound processes are there in the system. Now the second case is, if more of the CPU bound processes are there in the system, then CPU will only be able to execute one process at a time, and all the other processes will be waiting for the CPU, right? And IO devices are also idle because there are no instructions or no processes which requires IO devices. So you are underutilizing your IO devices in this case, and hence your throughput is also less. So that's why there has to be a proper balance between IO bound processes and CPU bound processes, so that CPU is also busy and meanwhile your IO devices are also busy and overall throughput is increased, right? The second one is your short-term scheduler. Short-term scheduler works between ready queue and running queue, the ready queue and the running state. It picks up a process from ready queue and assigns CPU to it, right? Why do we call it as a short-term scheduler, and why do we call the another one as long-term scheduler? Long-term and short-term schedulers are named based on the frequency or based on the frequency of their execution. As we know that CPU changes its context among processes very rapidly, that's why we say that the scheduler which is responsible to schedule processes on the CPU is named as short-term scheduler. It has to execute in very short span of time. and whereas long-term scheduler picks up a new process and submit it to ready queue. So the frequency of submission of new processes into the system is not very fast, or you can say it is slow. That's why we say that the long-term schedulers, right? We saw that schedulers or the context switching of the CPU is overhead to the system. Now let's have an example in this regard. CPU takes 10 milliseconds for selecting a process to execute for 100 milliseconds. What is the utilization of CPU? So this 10 milliseconds is required to select a process from the ready queue and placing this to the CPU, right? So we have to find out the utilization of CPU in this case. So utilization is the useful upon or the used upon total available. So used in this case is 100 millisecond only, because CPU's task is to execute something and it is executing for 100 millisecond. And the CPU was used for 100 millisecond plus 10 millisecond while selecting the process. The CPU was idle. So for how long CPU was available to you? 10 millisecond when the process is selected. Okay, instead that during that time CPU was idle, fine, but still that was reserved for your this system, or that was idle, that was not executing anything. So 10 millisecond plus 100 millisecond is the total time availability of your CPU, right? So utilization of the CPU is equal to useful is 100 millisecond upon total is 110 millisecond into 100. So this is the utilization of your CPU in this case.